Then.
Good morning, Year 7, and welcome to Home Learning Week 9. This is very strange for me, and it's going to be strange for all of you too. However, we're going to work together to make this a very thought-provoking and engaging lesson. So, just some house rules before we begin. This video is being recorded, as we are going to post this video onto YouTube. So for the students who are missing out on this lesson, they'll be able to watch this backwards. So what this means is that your cameras and microphones must be off. The only microphone that should be on is mine, because I'll be teaching the content. There are also staff here present which will mute you or remove you from the chat if any behaviour is going out of hand. So the recording has started at 10:05, and listed below is the equipment that you need. So you will need a pen, a pencil, ruler, protractor, compass, paper, and work pack. If you've got all of these together, then you should be all ready to go. But there will also be opportunities in this lesson to grab equipment if you're missing it. And another house rule to finally put this all together is that I don't want to hear any phones or any inappropriate chatting within the chat box. This is primarily for maths. So if you want to have social conversations, please do this on your own social media outside of this lesson. We wouldn't do it in the classroom, so we're not going to do it here. Now, just like every lesson, we're going to start with a do now. I'm going to time 5 minutes for you to complete this. And when you hear this sound, that means your time is up. So you are being timed 5 minutes to do the do now. Off you go.
I didn't.
You now have 2.5 minutes left. You have 1 minute left. So you now have 20 seconds left, so finish off the question that you are doing, and within these 20 seconds, we'll be going through the answers. Okay, so let's go through the answers together now. So if we want to list the factors of 28, which is question 1, these are all 6 factors that you should have listed. 1, 2, 4, 7, 14, and 28. Remember that a factor is a number that divides into another number and leaves no remainder. So if we list out all the possible multiplications using whole numbers that we can make to make 28, we should have these 3 multiplication pairs. So we should be able to list the factors like so. So question 2, convert 108 seconds into minutes. You should have had 1 minute and 48 seconds, and this is because if we know that 1 minute equals 60 seconds, we should be able to take this away from 108 seconds and see how many seconds we have left. We have 48 seconds, which we can't really convert into a minute, so we should have 1 minute and 48 seconds. Question 3, simplify negative 40 plus 5k plus 8t, take away 12k. You should have 40 subtract 7k. If we look at this expression, we have t's and we have k's. Remember from lessons that we want to be able to group up all of the t's and group up all of the k's. So it's just like collecting like terms, which we are more familiar with in lesson. In order to help myself in this, what I did was that I swapped around the 5k and the 8t using commutativity, just like so. And we know that this will mean the same thing. And what this also does is it allows me to see a bit more clearly how many t's and how many k's we've got together. So if I've got negative 4t plus 8t, we have 40. And if we've got 5k take away 12k, we have negative 7k. Question 4, solve 6 times 9, take away 12 divided by 4, we should have 51. This is because if we think about the rules of BIDMAS and we look at the operations we have here, we know that multiplication and division, so the D and the M, come before the subtraction, which is the S in BIDMAS. So if we did the multiplication, so 6 times 9, we've got 54, and we've got 12 divided by 4, which is 3, so we are left with 54, take away 3, which is 51. 5. What is the LCM of 24 and 300? We should have 600. Bearing in mind this question probably would have taken a bit longer to do, but that is absolutely fine. LCM stands for lowest common multiple. So remember in class what we would have done is we would have made these numbers as a product of their prime factors, just like so. So we're just going to whiz through this. This is the kind of thing that you should have done if you've done it this way, but if you've done it another way and you've got 600, that is also perfect. So what I did here was I made a Venn diagram, and then using the prime factors, I was able to eliminate from each list where the prime factors go into the Venn diagram. And then what I was able to do was I was able to multiply each number I see within the Venn diagram. So this would have been 2 times 2 times 2, times 3 times 5 times 5, which would have been 600. Now, for those of you who would have got into the extension question, I'm going to go through this with you. But if you've done any of these questions, that would have been fantastic, because this is all prior knowledge that you'll need to know for next year. So, extension question, we should have had 106 degrees. And this is because if allied angles in parallel lines sum to 180 degrees, which we would have learnt in previous lessons, we should have known that A plus B, which would have been 74 plus B in this question, would be equal to 180. So this would mean that B equals 180, take away 74 degrees, which equals 106. Now, what we're going to do is I'm going to leave 20 seconds for you to turn to page 38 in your work pack so that we can do this concept corner together. Fantastic, let's begin. So what I'm going to do is I'm going to read these, and then there's a diagram at the top which I'm going to go through step by step with you in the next slide. So let's start reading. If you know the length of the sides of a triangle, you can construct it using a pair of compasses. A triangle with side lengths 4 centimeters, 5 centimeters, and 6 centimeters has been constructed above. The side of length 6 centimeters was drawn using a ruler. So in this diagram, we can see this because this is the longest length which has been used as the base of the triangle, which I'll show in further detail in the next slide. And we can also see this in this diagram because in this diagram, each square is a unit square, which means that each side of the square measures 1 centimeter. So we can see that the baseline counts 6 squares. So let's go on. A circle with a radius equal to 4 centimeters was drawn at one end, which we can see on the left-hand side, and a circle with a radius equal to 5 centimeters was drawn at the other end. The triangle was formed by connecting the endpoints with an intersection point. So as I said earlier, I am going to show you how this would be done, or at least to the best of my ability, going to show you how this would be done if we were constructing this within our lessons. I have also decided to show you this in a more exam type question style so that you can recognise what this may look like. So this says, draw a triangle with side lengths of 4 centimeters, 5 centimeters, and 6 centimeters. What has already been drawn here excuse me, is a line that is worth 6 centimeters, and we have labelled it Y to Z. So it doesn't usually matter in other circumstances what length you draw first, but we usually decide to draw the longest length as the base because that is usually what is easiest to deal with. So we have done that. Then we are going to draw the 4 centimeter line. So the way that we would do this is we would use our compass. We would measure from the sharp point of the compass to our pencil 4 centimeters, and we would put the sharp point on the point Y, and we would draw a circle like this, which is worth 4 centimeters with a radius. Let me rephrase that. We are drawing a circle with a radius of 4 centimeters around the point Y, and this is roughly how it would look like. We would then do the same on the other side, Z, but with 5 centimeters, because this is what the question is asking us to do. So we are drawing this again. And then now, because we can see that the circles overlap one another, they have an intersection point. So we know that the other lengths of the triangle are going to meet that intersection point. So we are going to be able to draw these, and we are also going to be able to draw the lengths in, and we're also going to be able to label the vertex, or i.e. the corner of the triangle. So this would be our full construction if we had a compass and a ruler and a pencil. And this is also important to leave the construction lines so we don't lose any marks.
Copies of things I left there on.
So What we are going to do now is we're going to have a think about these different constructions that have been done. There are 4 different ones, and you should be able to see, just like the concept corner, they would have done this through unit squares. There are 2 questions that I want you to really consider here. What are the length of their sides? And what is the same and what is different between the triangles? What I would like you to do, and I'll be monitoring this in the 5 minutes I'm going to time you, is I'm going to ask you to put in the chat box what you can see the side lengths of the triangles are and what you can identify is the same and different between these triangles. The best answers will be getting a shout out when I go through the answers next. So once again, once you hear this sound, that means the time is up. So 2 questions, chat box, 5 minutes, off you go.
Miss,
Hello, yes?
the chat box disabled.
Oh, okay. Right, thank you for letting me know. So what I would like you to do is I would like you to write down some sentences.
Same with me, miss.
That's okay. We're going to write down some sentences, okay? And we're not going to be able to go through them in this scenario, but what I would like you to do is at the end of this, I would like you to email those sentences to me so I can award charter points for the best answers, and I will shout them out in our next lesson next week, okay? We've still got 5 minutes, or rather we have left 3 minutes and 55 seconds, so keep going.
Miss, I don't think I have the right workbook.
If that's the case, then you need to email your maths teacher, okay?
Okay, thank you.
Thank you. You now have 2.5 minutes left. Keep going. You now have 1 minute left. So now we have 20 seconds left, so finish off the last sentence you're writing, as within these 20 seconds we're going to go through the answers. Okay, time is up. So unfortunately the chat box has been deactivated, but I am really excited to see what answers you guys email me with, because I'm pretty sure that your answers are going to be much better than mine. But I'm going to go through what the side lengths are first and foremost. You should be able to see here that we've got 2 centimeters in question 1 for each side. We've got 2 sides of 2 centimeters and 1 side of 3 centimeters in question 2, and you can read for yourselves questions 3 and 4. And some of the examples I would have said is that, for example, question 2, you can see is an isosceles triangle, because you can see that there's 2 sides which are the same and 1 length is a different length. And for example, question 4 is scalene, because there's 3 different sides. A similarity, for example, this one's a bit rubbish, but I'm sure you guys can do much better than me. They all have at least 1 length of 2 centimeters, which is obviously a similarity. And the key thing here is that they were all constructed using 2 circles. So some of you would have just practiced constructing triangles with your teachers just by using arcs, but some of you would have used circles, and either of them are fine, so long as you have that practice with the tools. Okay, so we're going to move on now. So just for the purposes of the YouTube video, you should now be able to complete page 38 to 39, questions 1 to 5. So for those of you who are live with me, you can complete these questions after the lesson, but if you're watching this on YouTube, please pause the video and take some time out to answer these questions now. Okay, so again, I'm going to time 20 seconds so that you can turn to page 42 in your workpack. Okay, so again, we're going to read through this together and you guys are going to fill in the gaps, and then we're going to go on to an activity which I'll explain in a minute. So let's start. We can draw different triangles that have the same interior angles using a ruler and a protractor. So remember, the interior angles in a triangle are the angles formed by the vertices, or if you are better with this kind of terminology, the corners of the triangle. And we have practiced in lessons how to draw angles in a triangle as well. In the example, a horizontal side of length 4 centimeters was drawn, and then 2 line segments were drawn. So you can see that on the left side of the diagram, one at 48 degrees and the other at 25 degrees to the horizontal, so the baseline. The same process was then completed starting with a 2 centimeter side, so the right side of this diagram. Both triangles have the same interior angles, 48 degrees, you can see that, 25 degrees, you can also see that, and 107 degrees. Just to remind you how 107 has suddenly appeared, we can do 48 plus 25 equals 73 degrees. We know that interior angles in a triangle sum to 180 degrees. So we know that 180 take away 73 would give us the last angle. So that would be 107 degrees. Okay, so let's go on to this. In this, example we've got here, we are mainly going to focus on how to identify similar triangles. So we're not going to necessarily construct them at this point. We are just going to use our knowledge of interior angles and how to calculate them to see if they are similar. So in this example, it's asking us, are these two triangles definitely similar? And how do we know? Well, we definitely know that they're not the same. I mean, the left image shows a side of 3 centimeters, and the right picture shows in that same space 5 centimeters. So of course they're not identical, but we can check if they're similar. And we can do this by checking that the 3 angles are exactly the same. So let's go for the left image. We know that 40 degrees plus 60 degrees equals 100 degrees. We can do that. And we can do 180, so the sum of interior angles, take away 100, which is 80 degrees. And that's our missing angle there. Surprise. So in the right image, we can do 40 degrees plus 80 degrees, because those are the 2 angles we can see. We've got 120 degrees. And then we can do 180, take away 120, which is 60 degrees. And there you go. That's our missing angle there. Now, are these angles the same? I'm hoping that you're saying yes, miss, because they are. The angles are the same. So the main thing you need to remember here is the interior angles are the same and the lengths are different. Therefore, they are similar triangles. And then we are going to do some further work in this in GCSE, but this is the main information I want you to focus on right now. Okay, so on to the activity. We've got 6 different triangles here. What I would like you to do, because I'm going to give you 5 minutes to do this, there are 3 questions that I want you to focus on. So for each triangle, I would like you to calculate the missing angle of each triangle. So for example, for triangle ABC, we've got 60 plus 81 to deal with, and then I'm going to let you figure out what you need to do next. Then the second question is, which triangles have the same 3 interior angles? So are there any pairs of triangles that have the same angles within them? And using this information, we should be able to solve C. How many pairs of similar triangles do we have here? Now, I would encourage that you don't use calculators so you can practice your addition and subtraction, but if you really need to, I'm not going to stop you. So I'm going to time 5 minutes. So once again, when you hear this, that means your time is up. So 5 minutes, solving missing angles, off you go. You now have 2.5 minutes left. You now have 1 minute left. Keep going. You now have 20 seconds left. So please finish the working out that you're doing, whether that be the missing angle or which triangles have the same angles, that's fine. But within these next few seconds, we'll be going through the answers. Okay, so time is up. So we're going to go through these quite quickly, but no matter where in the process you are, it's great to even figure out missing angles and interior angles and triangles anyway. So I'm pretty impressed with wherever you are in this. So let's go. So if we're going to find missing angles in the triangle, for triangle ABC, you should have had 39 degrees and you should have had this kind of working out. And then for DEF, we've got this working out. And then we've got GHJ. And then we've got KLM. It's a bit harder to see because it's yellow, sorry. NPR and STV. I'm going to give you guys about 20 seconds just to double check your workings out. And just to see if you have unfortunately got them wrong, you can see now why. So we're going to move on now to which triangles are indeed similar. Do you remember that you can replay this video? So if I am going a bit too fast for you, please don't worry. You can check this in your own time. We should have had that KLM and STV are similar triangles. DEF and GHJ are similar triangles. And ABC and NPR do not have a similar triangle. They're lonely. So that means we have 2 pairs of similar triangles here. Okay? So just for the purposes again for the YouTube video, you should now be able to complete page 42 to 43, questions 4 to 7. So if you are live with me, you can do this after the video. And if you are watching this back on YouTube, please pause the video now and take some time out to answer these questions. Now, again, I'm going to give you 20 seconds to turn to page 44 in your work pack. Okay, let's start to read this together. You can construct different triangles if you are given two side lengths and one interior angle. As you can see in the diagram above, they look different, but you can see that you can form different triangles if you're given that information. So, for example, both of the triangles above have side lengths of 4 centimeters and 7 centimeters and an interior angle of 32 degrees. However, the positions of the angle and sides are not the same and they are not identical. So, in the next example, or rather the next slide, I'm going to show you how to construct a triangle with such information. You guys may find this a bit quick, but you are going to be able to watch this back, and you are, from prior knowledge as well, you should be able to construct angles and sides of triangles anyway. So this is just a recap, okay? So let's go on. So here's a triangle that we want to construct. Use a ruler and protractor to construct the following triangle. We are given 9 centimeters, 40 degrees, and 7 centimeters. Cool. So first, we need to accurately draw the baseline using a ruler. It does not matter which length we use, as we've discussed earlier in this lesson, but generally, and just like most of the maths teachers here, we like to use the longest length as the base length. So we're going to draw 9 centimeters at the bottom, and we can call the line AB, just so we can see that this is a separate line from the others we're going to draw. Now, we need to use a protractor to accurately draw in the angle of 40 degrees. So it doesn't matter if you draw this from point A or from point B. It really doesn't matter, so long as you can use your protractor to measure the angle accurately. So just because this one, I just fancy using the protractor at point B, I'm going to align my protractor so that the center of the protractor is at the end of the line. I'm going to make sure that the bottom of the protractor is lined up with the line as well, and it starts at 0 degrees. So from 0 degrees, I should be able to count or go round up to 40 degrees and mark the line here, just like we've done in lessons. And then we should be able to construct a line. Now, we know that this is 40 degrees because we have labelled it, and we always should label our angles in triangles and constructions. But we want to make sure that this line is 7 centimeters in this example. So we can cut that to 7 centimeters, which we would do by using a ruler. And then once we've got that, we can join point A to this part where it says 7 centimeters. And then we have constructed the triangle that they'd like. Again, it doesn't matter which point we draw the angle from or which point we measure 7 centimeters from, so long as we use that information accurately like we've done in previous lessons. So once again, just for the sake of the YouTube video, you should now be able to complete page 44 to 45, questions 1 to 4. If you are in the live lesson with me, you should be able to do this after the lesson. And if you are watching this from the YouTube video, please take some time out now to answer these questions and pause the video. Now, we are coming to the end of the lesson, so I am going to give you 5 minutes to complete as much of this exit ticket as you can. I appreciate that some of you may not have the equipment, but if you don't, please make sure that you practice your use of finding out what interior angles are missing, or if not, you can always finish off the questions that we have done earlier in the lesson if you don't have this equipment. But just as always, I'm going to time 5 minutes so that we can do this exit ticket. I'm going to go through the answers, but once we hear this sound, that means your time is up. 5 minutes, exit ticket, off you go.
ما عليه طبعا.
You now have 2.5 minutes left. You have 1 minute left. So you have 20 seconds left, so finish off the question that you are on, as we are going to briefly go through the answers and then recap what Hegarty homework you'll be doing this week, which is due next Wednesday before our lesson. Okay, fantastic. So just to quickly go through the exit ticket, you should have something like this. So again, if you have gone through previous questions earlier from the lesson and you have worked on interior angles, this is fine. But if you have completed the exit ticket, then congratulations, because these are hard questions, especially the second one. So long as you feel like you have learned something and you've recapped sufficiently, then that is the best thing that we could have done for this lesson. So just to recap, you need to complete Hegarty tasks 666 and 683. On Satchel 1, it does ask you to take a picture of one of your constructions and send this to your teacher as part of the Satchel homework, and you can do this on Show My Homework as well. If you've got any questions about this lesson, then please message me, because I'm going to be dropping my email in the chat before we end this call. And if you've got any questions about the Hegarty task, please email your usual teachers. So I am going to stop recording this now, but I am going to be here for the next couple of minutes to answer any questions. But until then, I hope you've enjoyed this lesson, and I'll see you next week.